All right, Math 1, Part 3 to the Order of Operations Proofwriting video 1.7. I'm just going to go through these two examples and try not to make them long, drawn-out explanations. We're just going to move through it step by step. All right, so step 1, I'll even number the steps. We rewrite the left-hand side and say that's our given statement. And I think a good move would be to get rid of those parentheses that just have a single number inside and rewrite them as multiplication, because that's really what's going on. All right, that's our given. Second move is I see exponent inside the brackets, so I'm attacking that right away. Two times 2 is 4. So I'm going to go 2 squared equals 4. We saw in our very first example that squaring a number and just setting it equal to 4, nothing special. It's the discard property, substitution. Oh, and keep in mind that that minus in front does not mean I'm taking -2 times -2. I'm still just saying 2 times 2. All right, next move. I see division, multiplication, multiplication. I'm going to deal with that division and turn it into a fraction first. So hopefully you guys can see that it is division. So I might have to do the work over here first. 17 divided by 34 is the same as 17 over 34 as that fraction. And then you ask yourself, does the top and bottom, do they divide sort of like a common term? And it ends up that 17 times 2 is 34. So if I divide the top by 17, I get 1. And if I divide the bottom by 17, I get 2. So 17 divided by 34 is the same as 17 over 34, which is the same as 1/2. All right. So taking a division statement and reducing its fraction is the same as substitution. So that sub step is going to get probably a lot of action here in terms of how many times you use that property. So I'm taking the 17 divided by 34 and I'm rewriting it as 1/2. Still times 2, still times 4, still minus 4. All right, next move would be inside the brackets. 1/2 times 2. Hopefully by now we've seen that enough times where you're like, yeah, 1/2 times 2 is 1. Okay? So I'm going to say 1/2 times 2 equals 1. And then we're backing that up with, if you scroll to your list, or just pause the video, check it out. All right, it's multiplicative inverse. Anytime you multiply reciprocals, the flip of the fraction, and you get 1, that's the multiplicative inverse. All right, inside the bracket, you get 1 times 4. That's 1. I'm sorry, that's 4. 4, not 1. Minus 4. In fact, I can kind of tighten this up a little bit, say that, the 3's here, the bracket's here. There's multiplication happening between the brackets, okay, and the numbers on the outside. Still got the plus 1 out here. So what did we do? We said 1 times 4 was 4. And this would be the multiplicative identity because you're multiplying by the thing that gives you the mirror image back. All right, so now we're getting close to the bottom. 4 minus 4 is 0. And at this point, if there's a single number inside the brackets, I'm just going to ditch the brackets and say multiplication, because this whole thing was 3 times whatever was inside the brackets. So 3 times 0 plus 1. 4 minus 4 equals 0 was the move we made on that step. And if you check your list, it's additive inverse. All right, now I can't really scroll down any further, so what I'm going to do is off to the side here, I'm just going to finish it out as sort of like the 3 times 0 plus 1. So this is where we left off, okay? And we were almost done with the proof. So 3 times 0 has to come before 0 plus 1. This would be 0 plus 1. You did 3 times 0 and got 0. If you look at this, if you look at the properties, that's multiplicative property of 0. All right, and then your last move, 0 plus 1 equals 1, which is what we were trying to prove it from the get-go. So we're done. You'd say 0 plus 1 equals 0 equals 1. That's the additive identity. That's whenever you add 0 to a term and you get that term back. So additive identity when you take 0 plus anything. All right, so let's just span the whole proof here for a moment. You got that going on. And this was at the tail end at the bottom. Now, I would like to say that I believe you could have done 2 steps at once up here. 2 squared equals 4. You could have also done the 17 divided by 34 as a half in that same step, because they were separated, this string of division and multiplication, and this exponent is separated by a minus. If things are separated by pluses and minuses, you can do steps at the same time. Yeah, and we'll see if that shows up on the third example here. All right, last one. So you've got your given. That's the first thing we do. Okay, brackets mean parentheses, so we've got more parentheses. That 2 squared's got to happen first. Since there's no separation of pluses and minuses, I'm not going to do the 4 divided by 16 just yet. So this would be now 4 inside there. Everything else remains the same. We said 2 squared equals 4. If you check your properties, that would just be a straight up substitution property. We substituted 2 squared with its computation, 4. All right, next move. You know what? Why did I put parentheses down? There's nothing happening in the parentheses. Just put multiply. So it's 3 minus. The 4 divided by 16 needs to transform now into a reduced fraction. So what does that look like? 4 divided by 16. It looks like 4 over 16. And then you reduce that fraction. Divide the top by 4, the bottom by 4. And you get 1/4. Again, that's another substitution property problem. When we're dividing and it just ends up being a random fraction, that is going to be substitution property to justify the step. Yeah. So I replace this with a 4th, still times 4. Still in the brackets, and there's a 3 on the just hanging out right here. We probably should establish that this is multiplication, even if it's behind, and there's no operation stated in between the bracket and the 3. That's multiplication. Anyway, back to inside the brackets. We got one more thing we got to do. We've got 1/4 times 4. That's going to equal 1. All right, so I'm just going to, we got one number inside the bracket now, and if it's being multiplied by 3, I almost feel like we can just write this as maybe 1 times 3. Yeah? And there's still a -1 at the tail end of this. So then we've got 1/4 times 4. That equals 1. You've seen this a few times. It's the multiplicative inverse. All right, we're down to subtraction, multiplication, subtraction. Multiply or divide has to come first. So 1 times 3 is 3. And this is still a 3 minus 1. So 1 times 3 is equal to 3. We've seen this before too. Anything times 1 is the multiplicative identity. All right, we're down to sort of like the last couple steps. 3 minus 3 is 0. And this is just another version of the additive inverse. If you add or subtract and get 0, it's an additive inverse. All right, last move. 0 minus 1. It's actually kind of the same as 0 plus a -1. I don't know if that helps you guys. We were looking for -1 from the very beginning. 0 plus -1, or 0 minus 1. That is when you add the identity, the 0, the thing that gives you the mirror image back. So additive identity is our last move. And we've successfully completed an order of operations algebraic proof. We've basically done these 3 examples plus the 4th one that was kind of like the first one to usher in those properties. Yeah, so guys, do your best to follow it with very clean steps. You're justifying every single calculation move you make. So, I mean, that's what a proof is all about. So please, watch these videos and yeah, ask questions for the things that just don't seem to make any sense at all. All right, thanks for watching.